Welcome back to another primer on Linux, and ironically I have a Microsoft Windows 95 wallpaper, even though I will talk about devices on Linux specifically. Now, say a device in Linux, what do we mean by that? We mean, technically we could mean hardware, but it isn't just hardware. It's anything the kernel presents. It's something that we can read and write to. In Linux, we know that everything is a file. That includes a real hardware like disks, keyboards, printers, but also virtual devices like dev/null or pipes, interprocess pipes. Devices live in dev and are called device files or device nodes. They look like files, but when we interact with them, the kernel passes our request to the proper device driver. On that note, let me move my tablet here and let's center it. I should have done this earlier. This should be okay. Let me open another terminal window. I'm gonna leave it right here. When we run the following command, list everything that we have in dev, we see files, and some of these files are starting with C, some of them are starting with D. I think there's also P or S. The first letter tells us the type of the device, because C is the character device. It works with data streams, one character at a time. And once we send it, it's gone. We also saw, I think here for USB we have D, which is a directory, but we should have also something else here. There is B. B is the block device, which means stores data in fixed size chunks, like disks. Disks are block devices. It allows random access. We can jump to any block quickly. We should also have pipes. I don't know if we have pipes here. We should also have pipes. They start with P, which is a named pipe. Lets processes talk to each other using streams. We also have S or socket devices, which are used for inter-process communication. What happens? Now, I mentioned something called a directory called dev null. And dev null is nothing more like than a special device file. Anything that we write to it just disappears. The kernel accepts the data and then throws it away. If we try to read from it, it gives us nothing. It gives us end of file immediately. In a sense, it's a black hole for data. And it's useful. It might not sound useful, but we could, for example, use it to throw away unwanted output. I could do ls, and also I could do ls dev null. We could use it to silence errors, or we can mix it with other redirections. We can do, for example, this. Let's do an example. Echo hello. Let me move this maybe a bit down. Echo hello. Let's output it to dev null. Nothing. It vanishes. We have no storage. We have no logs. Nothing. We are yelling into the void here. Yeah, we can use this, as I said, because it returns nothing. We can use it to run commands that are, for example, super noisy, that print thousands of lines we don't care about. And we can redirect the output into dev null and silence. So let's say good for noisy commands. let's just do an example on what happens when we try. I hope I'm gonna draw this correctly. So hopefully this is a USB device. And I know they have something like this here. And then this goes here. I have no idea why I like to draw these things. Probably because they make it easier for me to remember. So what happens when we plug in a USB stick? So first, the hardware is noticing something change. Let me move this. Noticing something change. It says, all right, something has been plugged into the port, and it tells the kernel. The kernel says, and it asks the file that is being plugged, what's this? And the stick replies, I'm a USB storage device. The kernel then loads the right driver and says, okay, you are gonna be kernel says you are gonna be dev/sdb now. If the stick has a partition, that partition would become dev/sdb1. At this point, the device is there, but it's just raw data. That's where udev comes in handy. udev is creating the actual file entries in dev, so the user programs can see it. And then, if we are on desktop, we're gonna see another layer automatically will be mounting for us under media/username/USB label. That's the moment our file manager pops open and you can start clicking around. From that point, every time we open, save, or copy a file to our USB stick, the kernel is just translating those actions into block reads and writes on dev/sdb1. Just to expand a bit on what udev is, it's a user space dev manager. It's a background process. It listens to the kernel for device events. When we have new hardware, when we plug in our USB, the kernel is saying device attached. It's a block device, USB, serial number ABC. udev is catching that event and it applies rules. It creates the right device file under /dev or /dev/sdb1/dev whatever. It sets the ownership and permissions, like who can access it. And it runs extra actions like triggering an auto mount, starting a service, launching a script. Now, what is the difference? Because, as we said, we have dev, and there's also sys. What's the difference between them? How is Linux exposing device info more structurally with this? As we said, dev is where we use devices. These are the devices files udev creates for us, like dev/sda when we put in a USB, or dev/now for the void. We can read and write to them. And sys is something else. Sys is where we inspect and manage devices. It's a virtual file system called sysfs that shows detailed info about how devices are connected, their attributes and kernel level stats. So with dev, we say, hey, here's a disk, you can use it. Here is a device, you can use it. And with sys, we are saying, here's everything about this disk, about this device, attributes, driver info, size, partitions, and stats. And we use sysfs because we want to see information about our devices. We want to see their ports, their buses, vendor IDs, and other things. For example, let's do Where's my terminal? Here. ls l. So what do we have here? Sys, a lot of things, block. Now we see here symbolic links for block devices. I'm gonna move this down. So these are the symbolic links for block devices, and we might have some devices here, and we can pick one of them. Let me just see what I could pick. Let's go loop 0. And here we see a bunch of files here. We see the size, which shows the total size of the disk in 512 byte sectors. If I do cat size, we see the size of it. We see what? We have slaves. Linux still holding it. Why do we have slaves here? I thought we have now, what's the name, progressive naming of these devices. So what do I see here? I see a lot of interesting things. I got 8. If I multiply this number by 5, 12. So that's the size in bytes. And maybe I can do cat stat. So this gives some performance counters and stuff like that. So what else do we have? So there is something called DD. Let me go back. I want to use DD in this example because this is my machine, this is my computer that has all my data and stuff like this. So I won't use DD, but DD is a row copier, it says here. So what it does, it takes data from an input and writes it to an output in fixed size blocks. Now, it doesn't care about file formats, it doesn't care about structure, it just moves raw bytes around. So DD is something called a row copier. Doesn't care about file formats or structure. So we can overwrite disks completely if we pick the wrong inputs and outputs. So I won't use it. Also, DD can stand for disk destroyer. Okay, how do we know the names and how do we name all the different devices we might run into it? So let's do some key takeaways from this. I'll move this down for now. Now, actually, I will need this, so let me move it here. If I go ls list dev, all right. Devices in dev follow conventions, so we can guess what they are based on prefixes. These names might not be stable if we replug devices or reboot. For example, dev STB might become dev STC or something. Now, we have hard disks, such as anything starting with SD, but I don't think I have anything here. For now, no, I don't have anything. All right, but ls dev sd. Yeah, I haven't. Why don't I have? I should at least have. I don't have any plug. I don't have any USB disks plugged in. Doesn't matter. What and where would hard disks live? They would live in the structure named dev sd wildcard. Because they show as dev sda or dev stb, the partitions also show as dev sda1, dev sda2, so and so. SD means SCSI disk, because Linux uses the SCSI protocol, which is not important right now. But if I do ls, can I see this? We also have virtual disks. We have SSDs. I don't have that, but what if I dev? Because I have a modern SSD. That's why I don't have any USB devices that standard disks. We can have device mapper, optical drives. What else do I have? ls, la, dev. Okay. If I do this, I should see dev SD partitions, mount points, and file system info. Can I increase this a bit? Yeah. You can also see all processes currently registered. Okay. And we can play with terminals, which shows which terminal device we are currently. I already mentioned indirectly udev. I think I also mentioned it directly because here I wrote about it. It's the user space device managers. So let me just see here again. Udev, user space device manager. Its job is to listen for kernel U events, device notifications, when we plug in USBs, when we insert DVDs, even though I don't know who uses this in the year 2025. It applies rules like namings, permissions, and symbolic links. It creates or adjusts the device files in /dev, and it optionally runs other programs. So without udev, we'd have I don't know, static dev folder, full. So if I go here, ls la dev, ls la dev, we would have thousands of pre-made devices here, which is the old school way, which would be messy, or device naming that changes unpredictably across boots. So what happens is that during boot, devices are needed early. Like we need our hard disk for root privileges, and the kernel creates temporarily device nodes in special memory file system, which is dev. Let me just write it. So dev t m pfs. This is a special memory file system where the kernel creates temporary device nodes. Once UDV is running, it adjusts permissions. It creates symbolic links, notifies other services about new devices. And we also have some rules where we can see. So if I go ls lib udev rules, so these are all the rules we have. And maybe I can do something like, let's do something cat 71 feet 71 feet. Why can't I see it? No such file or directory. 71 seat rules. Now, because it's a file, I can do cat. Now, these are all rules. What else do we have? Maybe I should find some simpler one. So yeah, let's maybe I should do something like this instead of looking directly here. udev ADM monitor property. So now I can see monitor will print the received events for udev and kernel. I will plug out my USB stick. Actually, not my USB stick. I have my I have my external Bluetooth mouse connected. I can move. I can move my mouse because okay. Let me use my touchpad. So we see there's a lot of data here. What we see is a uEvent scroll, and I should have an action. Yeah, remove. I should have dev path. There's a lot of. Let me just plug it in again. Oh, let me move it to the end. And maybe increase this a bit. All right, and let me plug it in again. Bam. Nice. And now I can use my mouse. And there's a lot of config points here. Basically, this is the kernel telling udev, okay, we removed a block device. We added a block device. Here are the attributes. Please do something. And maybe let me find some info about my mouse. Oh yeah, keyboard mouse. I need to find its dev. No, it's not this one. It's dev. Yeah, action add, device, dev pad. Where is it? Where is it? A lot of data here. What's the actual device file? Let me wait. Could it be? No, that's not it. Keyboard mouse. All right, let's test it. Let's test it. Exit. I don't exit like this. I exit like Control C. So it was either event 9 or event 12. I think I read somewhere. Now I can show you, but it was either one of these two. So if I do udf adm info query all name dev event 9, is it event 9? No, unknown device. Well ls dev. Um, uh, what is the name of it? What about if I... no, it's not this. What about if I list symlinks that you'd have created? No, this is not it either. All right, I need to identify the device node for our mouse. But I don't see it. If I do ls dev input. All right, so it's one of these guys. It's one of these guys. Dev input is at event 9. It should be, yeah, this is my mouse. All right. So it was not directly in the dev folder. It was in the dev input. Okay, so we see here some. Oh, there's a lot of information here. Like, what do we have here? What do we have here? ID vendor. There's a lot of ID vendors. ID bus, which is the type, which is the USB. ID, where's the pad? I should have a pad here. Which is the USB topology. Really interesting things. So yeah, it looks like a lot. Not all of it is equally important. What do we have? Dev name, the actual device node. We can open and read events from. What else do we have? Subsystem input tells us this is an input device, like a mouse, keyboard, joystick. What else do we have here? Major and minor. These are the kernel's internal numbers that map this device to the driver. They are rarely used directly, but they matter for debugging. What else? What else? ID input 1. This is an input device. ID input mouse 1. This confirms this is a boolean. It confirms that this is a mouse. If it was a keyboard, we would say ID input keyboard. As I said, ID bus USB connection type. This is the human readable model for the vendor. Now, what can we do with this info right here? I could do the following. Look at this. ID, let me close this. ID ls USB and then grep. Let me find the vendor ID 062 we have the vendor, and now we need the model ID for 101 4101. We need to confirm our device identity. So if I do this, here it is. Bus 001, device 014. This is my ID. And this is Semiconductor Corp wireless keyboard mouse. This is my mouse. Now, what else can we do? Oh, I know. Clear. So what I can do is I can run sudo. Do I have even this command? No. Dev input event. Oh, dev input event 9. I don't have this command. Oh, should I install it? I want to show every row input that the kernel sees from the device. This command will do this. But is it worth installing it? I could install sudo apt install ftest. Let's do this. Yes. And now I can run it. And if I move my mouse around, you see this? How can I close this? Okay, I closed it. Every mouse move, every button, I only move my mouse here, is printed on the line. So I have the event, I have the relative movement, nothing was pressed currently, so it's only relative movement based on X and Y. I could also search, if you remember, we looked at the rules. I can search R062A because this is the vendor ID. Let's search for it. Lib udev rules.d. Maybe we have some in etc udev rules.d. No. So it's most probably handled by a generic USB handler.